Yeah, I hope you guys choose a better diameter than we did for the rocket. We had like a really random diameter. I don't know why. Okay, so we got 22 people in here now, so we'll get started for today. I'm gonna share my screen. Okay, so today we're just gonna go over Matlab again. So let me actually see here. Sometimes I have an option to make a poll on Zoom, but I don't right now. I don't know why. I was gonna make a poll and see how many of you actually like feel good about your skills in MATLAB versus those of you that don't. So I don't know if you want to put it in the chat. You know, it's not anonymous this way, but how many of you feel pretty confident in your skills in MATLAB versus not on like a scale of 1 to 10? Not me, ha, yuck, 2, Kyle. Gotta be more than a 2, Kyle. Okay, so looks like we got some work. Some of you are decent, it seems like. Okay. All right, so that doesn't matter too much. We're gonna be able to, well, we're gonna go over some of the basics today in MATLAB. So first of all, I'm gonna go back to the course website here. So I added the schedule for week 2. But the first thing I want to talk about is the opting out of textbooks. So if you go on your main page for fullerton.edu, and I'm sure a lot of you already know this, but just in case some of you don't, you can click on your textbooks here. So like I have one for the other class I'm teaching. And then you can opt out because this semester by default, the school has opted you in to buy a textbook, the online version of a textbook, and you're going to be charged on September 9th or something like that. So if you want to avoid that, which I assume you want to do, you need to opt out. So you just click on opt out, give a reason, like not wanting to be, ripped off, and opt out. And I think they actually sent out an email like earlier or late last week, probably because there's so many complaints. Okay. So let's go back to the homepage here. So I already went over the layout last time, but just to refresh yourself, because I know Canvas is new. We're on the homepage right now for this course, going on week 2. And then I uploaded the slides for this week. So you can download those if you want to follow along that way. So we got a good amount to go over today. Hopefully it's not going to take too long. Okay, so we're going to review MATLAB and then go over Simulink, and that's it. Okay, and then guys, if you're not talking or asking a question, can you mute your mics? Okay, so let's open up MATLAB. So hopefully everyone has that installed. So we're going to open that up. I'm going to reset the color scheme. So this is part of what we're going to be doing today. Let me close out of that though. Okay, so for the lecture, I'm going to have the slides in the bottom right here so we can kind of follow along like that. Let me just resize it. Okay. All right, so hopefully you have MATLAB opened up right now. Okay, so first thing, what we're going to be doing today, reviewing MATLAB, already said that. And then we're going to go over Simulink, so the interface. We're going to talk about the library browser again, how we add blocks, how we can adjust the parameters. We'll go over some of the common blocks that we're going to use. we'll talk about exporting the blocks, or basically the results we have in Simulink to Matlab. And then we'll also talk about, I should have put this up before, but we'll talk about the scope block that's inside of Simulink. Okay, so some of this should be refreshing, or it should be a refresher from last time, but here's our main window. So this is the command window in the center here. We're going to use that a bit in this class, maybe, but for the most part, we're going to be writing scripts in this class. So to write a script, you're going to go in the top left here in MATLAB and click on New Script. Okay, so we'll click on that, and then you'll see this new window, this editor window, this is going to open up. Okay, so current folder, I mean, this should be pretty self-explanatory, but if you look on the left-hand side here, it's going to show basically the current folder that we're in right now. So you can also see your directory or your path up here. So you want to make sure, like if we were going to open up some script, like from your file browser, if you open that up and then you were going to run it, so if you press run, it's not going to do anything really right now because I don't have anything. But if you were running a script, it would say, you want to change the folder location. So you might be in a different folder location by default, but if you're running a script that you have, it'll go to that folder location for you. Okay, so editor window, that's what we're in right now. Again, we're going to be writing our scripts inside of here. And when we save this file, it's going to be a .m file. So that's just a script file. Another file extension that we have is a .mat file. So for that, that's when we save the workspace over here. I don't think we're going to be doing that in this class though, but you might do that sometime. Okay, we already talked about the command window. Are there any questions so far? I'm going pretty fast, but this is a like really basic review so far. Okay, and yeah, if you ever have any questions, just you know, put a comment or use your mic. Okay, so first we'll talk about the command window here. So this is where we're going to see output for our scripts once we start writing the scripts if we don't suppress a command or a calculation with a semicolon. So if I type in x equals 5 and I put a semicolon, I don't have any output. So I should say I don't have any text output. So in the command window, nothing showed up here. But on the right, in the workspace, x equals 5, that shows up there. So we assigned a value 5 to this variable x that we just defined. I'll open up a script again. So if I'm in the script file here and I type y equals 2, and so I'm going to press run, it's going to ask me to save the file right now. So it's saving it in the current folder that we're in. So I'll just call it class example. We'll save it. And it just ran the file or the script. And then you see here, first I'm going to clear everything. So to clear variables in your workspace, basically in your memory, you're going to use the command clear. You can see that on the bottom here. Let me make this a bit bigger. Okay, so we're going to type clear, and that clears our workspace on the right over here. And then if you want to clear all the text, you just type CLC, and then that goes away. So I'm going to run this script again. So what I have right now is just y equals 2. If I run it, then in the command window here, it shows our text output. It shows y equals 2. And then in the workspace, we have y equals 2. So I didn't use a semicolon, so our output showed up as text in the command window. If I clear everything again, and this time if I use a semicolon and I run it, then it just shows that it ran the script, but it doesn't show the output for y equals 2. It's still in the workspace, so it's still stored in the memory, but I just didn't want it to show up in the command window. And this will be, very useful if we're typing something out in our script file and its output is really large, like if we have a really big matrix or something, we won't in this class, but just an example, if we have a really big matrix and we don't suppress that output, we could have like thousands of lines of code. So if I do, we'll go over this soon, but so right now I'm creating a row vector from 0 to 100 with a step size of 0.01. So I'm actually not going to suppress this and watch what it does right now. So it ran pretty fast, but this is the command window now. We have 10,000 columns basically. So there's a ton of stuff here. That's obviously, not very useful to us. I don't want to see that. So in this case, you want to suppress it by using a semicolon. Okay, so for my setup here, I can't click and drag the command window back. A little weird because of my OS I'm using. So I'll just go back to default. Okay, so now I'm going to clear everything again, and that's good. Okay, so we'll go on. So another thing, if we're typing commands in here in the command window, like x equals 10, y equals 8 or 9, I guess. If you press the up arrow on your keyboard, then it's going to show all of the previous commands that you've written inside of Matlab. So this will be a good way if you want to look at some stuff that you wrote before, or if you want to, access some line of code again, you can just do it that way. So let's say I want to go up to this line of code here. This is for my color scheme. I don't know if I went over this last time, but that's a slide in a bit, so I'll talk about it then. So if I wanted to edit this line of code and I scrolled up to it, then I can press the left arrow on my keyboard, and then it's going to let me edit this code in the command window. Yeah, they're arrows, yeah. So if you want to access a previous command, you press the up arrow. And if you want to edit that command, you can press the left arrow, and it's going to take you now on that command, on the line for that command. And then you can use the left and right arrows to navigate left and right. Okay, so the workspace, so again, that's on the right side of our screen here, and that's where our variables are stored. So, we'll define stuff. Right now, it's just basic stuff like x equals 10 and y equals 9. So if we have some variable, that's going to store some data basically, and that'll be in the right-hand side here in the workspace. So if I want to look at the output, so let's say I have a row vector. So let me run this again. So our workspace now, it has our script here. It's storing those variables from our script. So if I have a big row vector or something that has a lot of values, I can double click on it in the workspace. Just double click on the variable, and then I can see all of its output right here. So, in this case, we have 10,001 values here. So there's quite a lot, but I can scroll through it using this right here, using the scroll bar. And then we can see the output that way. So another thing we can do is go in the command window, and we can just press whatever we want to see, like type it out. So if I wanted to see that row vector, I can just type X in the command window with no semicolon. So if I ran that script and now I want to see the output for X, just press X, and then we can see all of that output. Okay, so I'm going to clear the text. Any questions so far? And if I'm going too fast to you, then let me know.
Are you gonna go over if how to exactly get the column for the number? Like, because I know you said if you put X, it'll give you the whole sheet. Is there a way you can get like individual numbers just by doing
Yeah.
like X3 or something?
Yeah, I'll talk about that in a bit. Well, since
Okay,
brought it
thank
up,
you.
I'll talk about it right now, but it's a slide for later too. So for the row vector x that we created, if I want to see the value for the, I don't know, the 234th column, I can just do x and then 234 and in parentheses and press enter, and then it's going to give us that value for that column. Okay, so did I talk about how to have a dark theme last time?
I don't think so.
Okay, you guys want me to talk about it? It'll be pretty quick. Okay, yeah, see, for me, I like using a dark theme, so I figured a lot of you would want to hear about it. Okay, so when I first opened up MATLAB, it was basically my dark theme. In MATLAB, there isn't a true dark theme that you can have. I don't know why. It seems, like a pretty standard thing that people want now, but they don't have that. So what we're going to do is we're going to use an add-on, and you can make a custom scheme yourself, but this add-on is pretty useful. So if you are in MATLAB and you're on the Home tab, you can click on Add-ons right here.
How do you, if that's not in our bar, how do we get the add-ons there?
And you're on the Home tab. So if you look up top in MATLAB, you should see all your tabs.
Oh, no, yeah, I was on the wrong tab. I got it now.
Okay. Okay, so again, you want to go on the Home tab. You can see that right here, and then we're going to click on Add-ons right here. And then that'll open this up. Okay, and then we're going to search for an add-on here called Schemer. So that's Schemer. And then you'll see MATLAB Schemer right here. So click on that. And I'm going to go a little fast here, but if you can't, go at the same pace I'm going at now, you can look at the video later when I upload that. Okay, and then you should see like an option to download it here. So let me just click on some different one. And yeah, so you should see an install button for MATLAB Schemer. So I'll go back to that. So I already have it installed, but you should see an install button right here. Okay, so you're gonna install that and then press open folder. And once you press open folder, it's going to change the current folder that we're that we're in here on the left. So at this point, you can close out of this window. And then let's see, I need to remember. Okay, yeah, so you're gonna go under Scott C. Low, I don't know. You're gonna go under this folder and then go under schemes. And then you can see all of these .prf files. They're gonna be our different schemes for having a dark theme. So if we want to set a theme, and they should have some documentation under the page we were just on in add-ons. But if you want to set a theme, you can do schemer underscore import, and then you're going to set whatever theme you want. So the one I usually use is called Monokai. And then you do .prf, then you press enter, and then it's going to change your theme. So again, MATLAB doesn't have a true dark theme, so we can't change the color of this top toolbar. We can't change the color, basically everywhere where it's a light color, we can't change that. And so again, if you couldn't follow along, you can look at the video again later, or you can look at the slides. I put them on in the slides as well. Okay, but for the class, I'm going to reset the color scheme, just so, I don't know, it's more familiar, I think. So I'm just gonna, so you can restore it by just going to preferences and then colors, and then restore default colors and apply, and then now it's reset. Yeah, I know, I'm like blinded every time I use it at night. Like last night I was working on some of this lecture, and yeah, your retinas are burning at night unless you have a dark theme on, so you might as well use it. And another thing here, so I'll briefly talk about this, just not to be too long, but you can also use MATLAB inside of a text editor. So we're going to be using Simulink a lot in this class, so it's not as useful, but like over here. So if I was going to open up a file that we have, I'm just going to do one that I was working on last night. Or I'll do the one that we're working on, yeah, last night. Okay, so right now I'm in my text editor, and right now I have a Matlab script that's opened up here. And I could run this script in this text editor. So right now I'm running MATLAB inside of the text editor. And then here on the right is the command window. So I don't think it's actually going to be able to run the script right now because it's trying to run a Simulink file that I have. But if you're just running some basic script, you can run it inside of a script editor, or sorry, a text editor, and then you can have like a full dark theme. And it looks nice. Okay, so it actually did run it for me. And right here, this is a graph we're going to get later today. But if any of you are interested in this, you can send me an email or something and I can help you out if you need some help with that. Okay, so we'll go back to MATLAB. All right, so now we'll talk about, again, some more of the basics in MATLAB. We already talked about how to assign a variable or how to assign a value to a variable. So we can go over that one. We already talked about suppressing output. So we're going to use a semicolon. And then to add a comment inside of MATLAB, we're going to use a %sign. So let's go back to the script here. I'm going to clear everything again. So if I typed z equals 5, it's going to run this. Go to editor and then run. Okay, so you see right now, you might get this dialog. So because I changed the folder for MATLAB Schemer, I'm in that folder right now and not in this folder for, where I have this script file stored. So MATLAB knew that, and it's asking me to change the folder automatically, basically. So I can change the folder here, and on the left side, it updated the current path that it's in for the script file. Okay, so the script just ran. We have z equals 5. We have all of our variables here. So I'm going to clear everything so I can add a comment basically anywhere I want. So let's say I want to add a comment before z equals 5. I do a %sign. This is a comment. And MATLAB is not going to try to run, any kind of computation on this comment because I have a %sign. If there's a %sign, anything after that %sign, MATLAB is going to ignore. So it's going to ignore this line here, line 4. And if I do a %sign after something, so this is another comment, it's not going to, it's going to ignore everything that's highlighted here. So if I run our script again, then it ran fine. So the same exact thing happened as it, happened before we added these comments. Okay. So the assignment operator, that's just the equal sign. So, the equal sign in MATLAB is a little different than in math. So in MATLAB, we need to have some variable on the left. So like m. So we need some variable, or we can have a word. So, word equals 200. And this will work for us. So if I run it, then we have this variable right here, word, and that's equal to 200. We can't have a number on the left side. So if I did 23 equals something, then we're going to get an error here. See, it says incorrect use of the equal operator. You need to assign a value to a variable and use the equal sign. And if you want to compare values for equality, use 2 equal signs. We're not going to be doing that, but basically what we have to do is rewrite this line of code to something equals 23. And then if we run it, then it works fine. Another thing, we can't, do like x minus 2 equals 20. That's not going to work. Even though x equals 18, just for math, it's not going to work here. We only can have one variable here on the left side. So we need to rewrite this to x equals 18. And now if I run it, that's going to work. Also, if you notice, I have two variables here now for x. So I had x equals 0 to 100. So this was a row vector. We'll talk about that in a bit. And then I have x equals 18 down here. And if you look in the workspace, it shows x equals 18. So you can basically write over some variable that you've defined in Matlab. So sometimes you want to do that, like if you're computing some value or some like parameter, maybe you're solving for density, I don't know, but maybe it's an iterative process. So you might have some value at one point, and then you're going to update that value at a different point. So you can do that inside of Matlab. So even though at this point here in line 2, x was a row vector, down here in line 18, I basically overwrote that value for x. So x is no longer a row vector on line 11. It's instead x equals 18. Okay, questions so far? I want to try to go over these basics pretty fast, but if you do have any questions or you're confused on anything, either ask now or you can stay after class, or basically any time afterwards is good. Okay. All right, so arrays. So we're usually going to import an array into Matlab. Yeah, for the most part we will, and that's going to be from what we have in Simulink. But it's still good to know how to make an array. Before we talk about that, so this whole time I've been typing clear into the command window in CLC. But what we really should do in our script file here, I'll add a comment for what we're doing. And what we should have is we should start out our script by clearing the memory. So we'll have one line for clear. That's going to clear all the variables. And we'll have another line for CLC. That's going to clear all the text. So we should do this because sometimes we're going to have some variable that's in the workspace and maybe we actually don't want that in there anymore. So we're going to basically run our script and it's going to clear everything inside of the workspace. It's then going to clear the text so we can have a nice clean environment here. And then it's going to run everything that we want to run for our script. So that's just something that's good practice so we can be sure that we're only working with the variables and the data that we want to work with. And then I don't have to keep typing out clear every minute. So now if I run this, okay, so that just ran. And if I run it again, well, it just ran again and everything, works well. And I don't need to type out clear. So let's do in the command window, I don't know. I'm looking at my water bottle to the right. So bottle equals 20. So in the workspace, we have bottle equals 20. So, for this script, I don't want to work with that variable bottle. It's not relevant. So if I was going to run our script again right now, then bottle, it went away. So I don't want to deal with bottle. Maybe I did at one point in time, but, for the script, I don't want to. So that's why we're going to be using these lines of code here to clear it. Okay, so for an array, we can have a row vector, a column vector, or a matrix. So to create a row vector, I'm going to delete some stuff here. So I'll type in row equals, and then we're going to make a row vector. So to make any array in Matlab, we need to first have our variable, then our assignment operator, which is the equal sign. Then we're going to start with a left bracket. and then we're going to define the row vector. So I'll do 2, 9, 8, 7, and then I'm going to close it off with a right bracket. And now if I run the script, in the command window, we have row equals 2987. So for this example, I have a space in between each number. So you can either have a space between each number or you can put a comma. So if I instead, I'll do row 2, and I'm going to make the same row, the same row vector. So if I do 2, comma 9, comma 8, comma 7, and then I run the script. Now we have these two row vectors. They're the exact same. One just has a comma and one doesn't. So this depends on what you think looks best for you. It doesn't really matter. And I could also have a comma and then a space. And that will also work. So if I run that, and it did run, because remember, we're clearing everything and clearing the text. And then we get that same output right here. Okay, so another way to make a row vector is how I did right here on line 9. So I'm going to suppress this stuff right now. So if basically we're going to be doing this kind of format when we're making some X domain. So, we're going to have basically it's going to be a time domain, but when we make a plot on our X axis, that'll be for time. And often we're going to want to make that vector ourselves. So we'll do T for time. So we'll do like 0 to 10. So I have a row vector that's going from 0 to 10. And in the middle here, I have 1. So that's the step size. So that's going to create a row vector, again, from 0 to 10, and a step size of 1. So let's run the code. I'll type in T in the command window. And then you see our output is 0, 1, 2, 3, 4, 5, 6 to 10. So when we make our plots, we're not going to want a step size that's, this large, because then our graph is going to look pretty bad. We're only going to have 10 data points then, or 11. That's going to be pretty bad. So a lot of times we're going to make our step size smaller, like 0.01. And now this is 1001 columns, or we don't want to actually see that output. So instead what we could do is we could type in size of T, and we see that we have 1 row and 1001 columns. Or we could just look in the workspace here and we see that it's a 1 by 1001 double, so it's 1 row, 1001 columns. Another way we can make a row vector is using the Linspace command. So let's do T2. So instead we can do Linspace, and now if I press a left parenthesis here, basically anytime you're typing a command in Matlab, if you type the command and then the left parenthesis, then this dialog box is going to come up. So maybe you kind of forgot the syntax for a command or what kind of arguments you could put in there. You can just do this, and then this dialog box will come up. And it's going to show you some of the options that you have for that command. If you want to read more about it, you just press more help. And then this dialog box is going to come up. You make it bigger. And then we can read about it. It's pretty good documentation just in here. Or you can, of course, just Google whatever command you want to look at. And basically, you can see this documentation that we're looking at right now, or you can look at the forums that MathWorks has, and they're pretty active. So there's a lot of help online. So for Linspace, I can't zoom this in really, but so it's kind of small, but it says for this argument here, y equals Linspace of x1 and x2. That's going to, x1, that's going to be the first value that we want in our vector. Then x2, that's going to be the last value that we want in the vector. And by default, that's going to give us a row vector of 100 evenly spaced points. So let's try this out right now. Let's do Linspace of 1 to 10. If I run this and then I type T2, and yeah, we have 100 columns. So I can just use size of T2. We have 1 row and 100 columns. Or I could do length of T2. And now this is just going to show 100 because we have 100 columns. Different argument for Linspace was, well, I'll show you. So if we do Linspace, we have x1, x2, and then n. So n, we can actually specify the amount of elements that we want. So maybe we don't, oops, I just closed that in Matlab. So let's say we don't want 100 points, maybe I want 50 points instead. So I can do T2 equals Linspace 1 comma 10. So that's going from 1 to 10. And now I want 50 points, so I can do it like that. We can run it, change the folder. And now T2, that's a 1 by 50 double. The length of 50, or sorry, T2, that's 50. Okay. Any questions so far?
So the length gives you the number of columns?
It's going to give you, if you have a vector, the number of elements in that vector. So it depends on what you're looking at, but if I had like a column vector, then it would give me how many rows we had. And if you have a matrix, it's going to be a bit different. I think for a matrix, it gives you the largest amount of either rows or columns. It depends if you have more rows or more columns, but I'm not 100% sure on that. I would have to check that again.
Okay, thank you.
Mm-hmm. Okay. So a column vector. Linspace. So Linspace, that just makes another, by default, it makes a row vector. So in these two lines here, 16 and 17, in both of those lines, we made a row vector. Let me change this to 0. So in both of these lines, we made a row vector from 0 to 10. So if I open up T and T2, we see for T, I have a row vector starting at 0, and then the last value is 10 right here. And T2, that also made a row vector from 0 to 10. Okay, so there's 10. But the difference between the two was the size or the length. So the length of T, that's 1001 because we had 1001 columns. And then the length of T2, that was a length of 50 because we had 50 columns. So we just made a row vector in just two different ways. So basically you'll use Linspace if you know where you want to start the vector and you know where you want to end the vector, but you don't know the step size. Okay, so we'll talk about, so we'll talk about column vectors now. So to make a column vector, instead of using a comma in between values, we're going to use a semicolon. So if I want to make a column vector, 298, and we run that, oops, I want to make a column vector, so use semicolons. So you're going to use a semicolon to terminate whatever row that you're on, and then it'll allow you to make a new row right beneath that current row. So, I'm starting at this column vector with the first row, which has a value of 2. Then I use a semicolon. It's going to create a new row. I put a value of 9. Then I put another semicolon, and then I put a value of 8. So then we made this column vector right there. I can also write it a bit differently. So we're going to write the same column vector, but go about it in a different way. So again, for an array, we want to start it off with a left bracket. So I'll do column equals left bracket. So now MATLAB knows that we're starting to make an array. Then I can press enter. And I can do 2. I can press enter again. 9, press enter again. Press 8. Then I can even press enter again, and then we'll have our right bracket. Now if I run that, so we have, let's do this. Okay, so we have column equals 298, and in that one I used semicolons, but in column 2, I wrote it out like this. So this is a more visual way to look at what you're doing, but it also takes a lot more space. So personally, I don't like using the method of column 2, but it's up to you. So now I'm going to suppress the output. All right, creating a matrix. So in this, we're basically combining the methods that we did for making a row vector, making a column vector. So matrix equals, we're going to start with our left bracket, and we're going to make the first row right here. So 2, 2, 2. Now I'm going to use a semicolon to stop that current row, and we're going to make a row underneath. Here, how about this? 1, 1, 1, and 2, 2, 2. That's the second row. Now I'm going to start the third row, 3, 3, 3. Now if I type in matrix, then we see our matrix right here. So we have the first row, second row, third row. Okay. All right, so outputting array values. So this will be more useful for us in the class. So we can look at the maximum value, the minimum value, the length of an array, which we already talked about, and the index of the last value in some array. Really, for this last one, I should have said the value of the last element in the array, but we'll talk about it. So if we want to find the maximum value in an array, we're going to use the maximum function. So in these slides right here, I typed in x equals rand 1, 10. So rand, that's a function in MATLAB that'll just generate random numbers. And here I basically made a row vector from 1 to 10. Just a random one though. All right, so I'll go in the script again. So I'm going to make some random array. We'll do rand 1, 100. So here I'm going to have 1 row and 100 columns. So now if I click on X, you see I have a lot of just random numbers in here. So if I want to see the maximum value in this array, or in this row vector, I'll just type max, so that's the variable. Max equals max of X. And then we see the maximum value in here was 0.9961. Okay. The minimum value, that's going to be basically the same kind of thing. We're just going to use min instead of max. So min equals min of X. And the minimum value in this case was 0.0287. To find the length of an array, we already discussed that, so we're going to just type in length for our command. So I'll do length equals length of X. And again, the length of an array is going to give us the number of elements in that array if you have a vector. So let's not suppress that. So in this case, our length was 100 because we made a random row vector for one row and 100 columns. Okay, and we already talked about the Linspace command as well. All right, the value of the last element in the array. Okay, so what I could do, I could just go in and I could double click on X in the workspace. And then I could go through here and I could go to the last value in the array. And I could go, oh yeah, it's 0.3181. But if we're doing this for like a lot of arrays or something, even just one, it's kind of annoying to do that. So instead, we can use the end argument down here. So I'll do, I don't know, last equals X, and then I'm going to put end. Now if I run this, it does 0.5828. So it shows a different number right now because we just ran the script again. It generated a new row vector with random numbers. So that's why it was different. I'll show you right now. And yeah, so for this current iteration for what I just ran, the last number in this row vector is 0.5828. Okay, so again, I think that one actually is pretty useful. Because I know for myself in some past labs, I've done this before. Okay, and then this up here, I basically showed a different way to find the value of the last element, but this is a more roundabout way to go about it. So I'd recommend using the argument end. Okay, so that's the review of MATLAB so far. I think there's a lot of information at once, so if you're kind of rusty on MATLAB, you might want to look back at this video to go at it at a bit of a slower pace. Or you can also look at the lectures that I have for this class that I'm teaching now on my YouTube channel, so you can see even more stuff at a slower pace. So any questions on MATLAB before we start Simulink? Okay. All right, so we're gonna start Simulink now. I'm planning on making 2 models today. So I don't want to take up too much time, but I don't think it should. So there's 2 ways that we can start Simulink. We can either go on the Home tab and then press Simulink up here in the top toolbar, or we can go in the command window and we can just type in Simulink. So I'll just do that and then I'll press enter, and then Simulink should open up now. In the bottom left here, it shows busy, so it's working on it. It might take a little while for it to open up, especially if you're on a bit of an older computer, but it'll open up. And so I'm going to wait just a little bit because some of you might still be getting it open. But we're going to click on blank model once you get to this window right here. Okay, so I'm going to click on that. And right now I'm going to maximize the Simulink window because we're just going to focus on that for now. Okay, so we went over this a little bit last class. So here's our main environment for Simulink. So we're going to click on Library Browser under the Simulation tab. And we're going to be using this quite a lot. So yeah, I'll put it up here. Okay, so this library browser, it's where we're going to drag and drop all of the blocks that we want to use inside of Simulink. Okay, so let's see. And yeah, we're going to be using these blocks to basically model a differential equation or an equation of motion that we made, in a class before. Okay, so a lot of the blocks we're going to use, they're going to come from the commonly used blocks here. So we're going to be using gain pretty often, the integrator block, maybe the product block every once in a while, the scope block we're going to use quite a lot, and the sum block. Okay, and then we can also import a block by left-clicking in the workspace and just typing out whatever block we want. So if I left-click here, and I type in gain, it's going to show me a lot of options here. So I want to choose gain from Simulink, and then it shows /math operations. So I'm going to click on that. And so basically it just took that from this library here. So here's the library for math operations, and then here's gain. So I could have also just clicked on it, and here, left click and drag into the workspace. I think last time I said I'm going to try to not call this workspace. I'll try to call it a canvas or something, because there's a workspace in Matlab and I don't want to confuse the two. The operations tab, so do you mean just this library block right here? Okay, so you want to go on the simulation tab and click library browser right here. If you're in a different version of Matlab, it might be a little different because I think they did change it a little from years past. But it should be called library browser. Is anyone else having trouble seeing that on their version of Matlab? Okay, you got it. Okay, so for this exercise right now, we're gonna get 2 sine waves, and then we're gonna plot it in Simulink. Then we'll export those sine waves and back to Matlab, and then we'll make a plot inside of Matlab. Did I show this last time? I can't remember, honestly.
No, I think we just looked at it, but you didn't show us, like, you didn't go in depth in it last time.
Okay, thanks. Okay, so the first thing we're going to do is get our sine waves. So I can go in the library browser here, and then I can go under sinks, or sources rather. I think it should be under sources. Yeah, so I have an error in the slides here, but to import the block, it's under sinks, or sorry, sources. So here's the sine wave. So I'll just left click and drag. And here's our sine wave. Or I could have just typed in sine wave on the Simulink canvas. So I can just do sine. And then here's the sine wave. So we're going to look at 2 of these. So what I can do, by the way, to zoom in, it's just scrolling on your mouse. So that's going to zoom in. And then to pan, you're going to hold down the scroll wheel on your mouse, and then you can pan around like that. So we want 2 of these. So what I can do, I can left click on this block, and then I can do Control C and then Control V, and that's going to paste it. I'm going to delete this right now, so I'm going to select the block and then press the delete key. Another way to copy and paste a block is just to right click on a block and then drag, and that's going to give us another block. Okay, so to change the parameters of a block, we're going to double click on this block, and then this dialog box should come up, and then we can change some stuff. So all that we're really going to worry about is the amplitude and the frequency. So let's change this amplitude to 2, and we'll change the frequency, I don't know, to 3. And then I'm going to click apply, and then OK. And then I'm going to change this name here. So what did I do? I did 2 and 3, okay. So I can change the name of a block by left clicking on the block, and then you'll see that the name for the block kind of shows up below. So now I'm going to click in here, or I could have, double clicked or triple click, and then I can just select it all. So I'm going to do sine 3x. Is that what I did? I already forget. Yeah. So I'm just changing the name mostly for me, so I know that this sine wave is 2 sine 3x. Now for this other one, I'll make it, I don't know, sine of, now we'll leave it as sine of x. Okay, so we'll change this name to sine of x. And once I'm done, I'm just left clicking outside. Okay, so we have our 2 sine waves right now. So on the slides, I'm doing something a little different, but that's okay. Okay, so now I'm going to want to look at the output for these sine waves. So I want to see, some kind of graph. So what I'm going to do right now is just left click and then type scope. And then I press enter, and then there's our scope block. You can also just go under commonly used blocks and then select scope from there and left click and drag. All right, so here's our scope block. This is going to allow us to see the output of whatever we want to look at inside of Simulink. So I'll do, I don't know, waves. I'll name it waves. And for this, if I double click on it, it's going to open up this graph basically. Right now it's empty because I don't have anything connected to this scope block. So there's nothing that it can show. So if you want to edit the parameters for this, you have to right click on it and then go to properties. So we're never going to change anything inside of the scope block though. And so here I can double click and I can change the properties, or I could right click and then go to properties, or sorry, right click and then block parameters. Okay. So we have 2 blocks and we have 1 scope. So I want to see the output for both of these sine waves on the same scope. So I want to see both plots at once. So I can go over here for sine or 2 sine of 3x, and you see once I go over this arrow, I get this kind of crosshair. So I can left click and drag. And then I can, move this around, and then I'm going to connect it to that scope right there. So by default, our scope only has 1 input. So right now I can only connect one of these scope blocks to this scope. And we want to see both of them. So, a little frowny face. I can't do that right now. So, at least on the new version of Simulink, I can just go here to the other one. Oh, look. And then this one just pops up. And then I can connect the other one. So if you're on an older version, I'll show you what to do. Hopefully I remember. Let me just go forward. So what I'm going to do now is I'm going to run the simulation. So I'm on the simulation tab and I'm going to click on run. And you see right here, we have a time field. So our simulation is going to run for 10 seconds. Now that doesn't mean 10 seconds for us. Our computer is going to compute through that simulation pretty fast, but the simulation is for 10 seconds. So if I run it, see my screen went a little weird for a second, so it just ran that simulation. Now if I click on this scope here, double click on it, then I get a graph. So I have basically 2 plots here. I have our sine wave, 2 sine of 3x, and then I have this blue line, and that's just because right now it has another port right here. So let's actually, I'm going to delete that scope block. Okay, so here's a scope. I'm just going to connect this. So right now we only have 1 input that's connected to the scope block. I'll run the simulation again. And now if I look at this output, now we only see this, this graph for 2 sine of 3x. So I want to have 2 inputs for the scope block. So you can do the method that I just showed you if you're on a newer version of Matlab. I don't know when they changed this, but I think like a few years back, they didn't have this option. Okay, so let's see if I can remember. I think, yeah, you gotta click on settings. Yep, okay. So you're gonna click on this cog right here for the configuration. And then I can just manually say how many inputs I want. So I want 2, so I'm gonna click apply, and then okay. Close out of this. And now there's our other input. So I'll go to sine of x, and then I'll attach that. I'm going to run this now. And now I'll double click on the scope block again. And now we have 2 graphs. So we have sine of x in blue, and then 2 sine of 3x in yellow. Okay. Have all of you been able to run this? Do you see the exact same output that I have?
Yeah.
Okay, cool. Just want to make sure I'm not going too fast. Okay, so yep, there's the output. Okay, yeah. So our output here, it's pretty jagged, right? I mean, sine of x here in blue, that seems okay. But 2 sine of 3x in yellow, that looks pretty bad. You know, we see these really jagged edges here. So we can change that. So I'm going to close out of the graph. Now I'm going to click on the modeling tab up top here. And this, so I think when I took this class, as in 2017, so for that version of MATLAB, this part is a little different for how you get to this setting. Right now I'm on 2020A, I think, for MATLAB. So if you go to the modeling tab, you should then see right here, it says model settings. We're going to click on that. And then we can change some of the settings in here. So I'm going to click on solver details here. So right now our time step, basically it's a variable time step. And it's doing our step size automatically right now. So it's just deciding itself, yeah, this step size is sufficient to make some kind of plot. But because it's doing it automatically, that's why we saw those jagged edges for the yellow plot. So we're going to change the maximum step size to 0.01. Then I'm going to click apply and OK. And I'll go back to the simulation tab. And then I'm going to click run. Okay, that ran. Now let's double click on the scope block. And now our graphs are a lot more smooth, at least for the yellow graph. So I'm going to do something different right now. I'm going to go back to the modeling tab, click on model settings, and then I'm going to change this from a variable step to a fixed step. And then my fixed step size here, I'm going to change this to 0.01. So I'm just doing this because, you know, this is what I have in MATLAB. Sorry. So 0.01, that's what I do in MATLAB most of the time when I'm making some X domain. So I'm just doing this because it's then I can guarantee that the length of our vectors are going to be the same for what I'm comparing. This will make a little more sense once we get around to that. So you don't have to do a fixed time step, but I'm just showing you how to do it right now. Okay, then I'm going to click apply. We'll click OK. Go back to the simulation tab, click run. I'll look at the output, and it's basically going to look the same. Okay, and I'll close out of this now. So now the plots look good. Okay, we just talked about that. And so yeah, this is going to increase the computational cost. Our simulation is going to be a little longer. Now this is a very, very simple simulation that we just made. So it's not going to be too long. So that's not going to be really an issue for us. Even the other labs that we have in this class, they're not going to be too computationally demanding. Okay, so now we're going to export to the Matlab workspace. Okay, so for that, so we basically, for this example here, I want to export basically the X and Y values that are associated with each sine wave here. And we're basically just going to plot it inside of MATLAB. So I can go to Sinks now in the library browser. And then I can click on the block that's to Workspace. I can click and drag that in here. That's a pretty big block. Okay, so now what I can do is I can go on this arrow, and then I can just click and drag it, and see I can connect it to this branch here. I can connect it down here, or here, or here, it doesn't matter. I just want to connect it to this, this wire, basically, that's connected to the sine wave. Okay, and then I also need to get one for the other sine wave. So I can for that, I just right-clicked and I dragged down from this block here to copy it. And then I connected it to Sine of X. All right, so we can run it again, and that'll just save what we have here. So I'm going to rename this now. So all I did here is I double-clicked on the block itself, and then it says variable name right here. So I can change this to 2 sine of 3x. Click apply. Invalid. Oh yeah, okay. So it's invalid. I can't name it 2 sine of 3x because I have a number in the beginning. Matlab doesn't like when you try to make a variable name with a number in the beginning. So and I'll do an underscore and then 2 sine of 3x. Then that should work now. Click apply. Okay, no, it still doesn't like it. So I'll just do 2 sine 3x. Now this should work. Yeah, okay. So that could be a little annoying, but we'll deal with that. Then I'm going to rename the one on the bottom, Sine of X. Click OK. And I'm going to run it one more time. Again, if I click on the output, nothing changed here. We still have the output. Okay, so for now, we're going to be done with Simulink for this project. Okay, so let's minimize this now. And now if I go back into Matlab here, I'll maximize this. I'm going to close the library browser. So now you see I have this variable here that's called out. And it says 1x1 simulation output or something like that. If I double click on it, so yeah, it's a 1x1 simulation output. And this is storing a lot of stuff for us. So it's storing the output that we have for sine of x and for 2 sine of 3x. And it also has t out, which is the time. So this starts at 0. It's going to go to 10 because we ran the simulation for 10 seconds. And then we have our step size as well of 0.01. Let's go back here. I'm going to click on sine of x now, double click on it. So we see the time right here. So that's just going from 0 to 10 once again. And then the column for data, that's basically the y value that we have associated with our time. So if we were going to plot, this data versus time, then we would get our sine wave. We would get that plot. And that's going to be the same thing for 2 sine of 3x. Okay, so I'm going to close out of that. So I'm just looking at our slides, making sure I covered it. All right, so now we're going to make a script. Okay, I'm going to close out of this script file that I've been working on so far because I'm going to make a new script. I'm going to clear everything. So I'm going to type in clear and then CLC. And I'll go to new script. Here's our new script. And I'll make a comment here, Simulink intro or Simulink sine class example. Okay, so I would recommend putting a comment, at the top of each script that describes what that script is for. And then we're going to clear the memory. Clear and then CLC. And if I press run, so I can press run or I can press save. Let's press run. And then we're going to name this script file. So sine example, save. All right, so now our workspace, it doesn't have that output that we wanted, right? That's gone. So I can go back to Simulink, and now if I press run, then it shows up here inside of Matlab. So it would be pretty annoying if I pressed clear, or if I ran the script right now, well, that goes away because I just cleared the memory. And there's nothing below those lines of code that says, yeah, take this Simulink simulation and put it inside of our script so we can use the associated data. So we want to be able to do that. So make another comment here called parameters. Maybe I should call this importing. import Simulink stuff. All right. So now basically what we're going to do is we're going to import our Simulink model. So you don't need to go into Simulink, run it, then it's in the workspace, and then you work on stuff inside of Matlab. That would get pretty annoying. So I'm going to assign a variable called out. Doesn't matter what you call it there. I'm just calling it out so I know that that's what I had for the SimOut blocks inside of Simulink. So go back here. You know, by default, it's called out and then dot whatever you named it. So for us, though, we don't need to use the variable name out. I just think it's kind of convenient because it kind of goes along with that, what's the word I'm looking for? That convention that was in Simulink already. So we'll do out equals sim. So the command sim, that's going to run the simulation inside of Simulink. And now we're going to put the file name that we have for that Simulink file. What did I name it? Oh, I don't think I ever saved it. Yeah. Okay, so go into Simulink right now, and we're going to save this file. Okay, and I'm going to call this, and you want to make sure that it's not the same file name as your script. So I'm going to go select all files here. And so my script file, I called that sine example. So I'm going to call this sine example underscore sim. And you'll see your Simulink file, that's going to be a .slx file format. So now we'll press save, go back to Matlab, and then you see it showed up here in the bottom. So sine example sim. Okay, so now we're going to put that name into here. So sine underscore example sim. And there we go. So we need to enclose it with quotes here, with an apostrophe. And then I'm going to suppress that output. Okay, so again, this line of code, line 8, that's just going to run our simulation inside of Simulink for us. All right, so something I want to do is get the time that we had. So I'm just going to do time equals out.tout. And basically that's going to look at this line of code here. It's going to look at that simulation. And it's going to take the tout parameter that we had. So let's run this right now. If I'm just looking at out, which again, that was from Simulink, it's just getting this, all of this data right here, all of this time data. So again, that's from 0 to 10 with a step size of 0.01. So I'm just creating a variable so I can use that output. Okay. Is everyone good so far? Okay. All right, so now we want to look at the plots that we had. So we had, what do we have? 2 sine of 3x, was that it? So I need to use different names, so I'll just do, I guess I could type it out again. 2 sine 3x equals, and now we're going to do out. So I want to look at this output now. So it's out dot 2 sine 3x. So we want to take this data inside of here. So we want to take this column right there. So this part is maybe a little funky. So we're going to do out dot 2 sine 3x and then dot data. All right, so this line of code, it's saying look at this simulation right here, or really look at this output from Simulink. So it's going under out, and then it's going under 2 sine 3x, and then it's selecting all of this data right here, this column vector. Those are the y values that correspond to the time, in this case, column vector. Okay, so now we have all of that data. If I was going to run this right now, and I now double clicked on this, and we see all of that data, so that's good. And now to plot inside of Matlab, if we have our x data and our y data, those vectors need to be the same length. If they're not, then we're going to get an error and we can't plot it. So you can see it in the workspace over here too, but if I do the length of time, that's 1001, and the length of 2 sine 3x, that's also a length of 1001, so we're good. I don't need to type clear, it's fine. Now look at the other plot, so sine of x equals out.sine of x dot data. So again, we're saying in this line of code, we're going to make a variable called sine of x, and we're going to basically assign data that's inside of this variable out, and then dot sine of x, so it's going inside of out, and then inside of sine of x here, and then it's selecting all of this data in this column vector data. And it's doing that by this dot data part right there. Older versions of Simulink, again, it might be a little different. If you are having any issues, then just, stay after class or something. Okay, so there we go. If I run this again, no errors, and then sine of x, that's also a 1001 by 1 column vector. Here we go. All right, so now we're going to make our plots. Any questions so far? Okay. All right, so we're also at 1250 rather. So I'm thinking I'll probably just go over this example and then I'll show you. I'll kind of talk about the code for the other example, but I'm not sure if I'll go through all of that today. We'll talk about that though. We'll see what everyone kind of feels like. Because the kind of the theory in there is pretty much the same as what we're doing now. Okay, but we're gonna make our plots now. So first off, I'll plot, 2 sine of 3x, okay? So we want to take for the x-axis, that's the first part that we have to do for the plotting command, we're going to plot time. Okay, so we have time, and then we'll do sine of x. And then I'm going to change the line width. I'm going to specify to use a line width of 2, or I had 1.5, so we'll do that, 1.5. And I'll just add a comment for myself so I know that's sine of x. And I'm going to type hold on. So the command hold on, that's going to allow us to say, hey, I'm not done plotting yet. I want to have another plot in here. So this will allow us to plot multiple curves on the same graph. So then I'll do plot time, comma, 2 sine 3x, then a line width of 1.5. Make another comment, 2 sine 3x. Okay, and then we're going to do hold off, because now I'm done with all the plots that I want to make. Okay, then we're going to have a title, and we'll first plot it. Okay, so I'm going to run this right now, and then we get a nice looking plot. So what I'm doing right now, I wouldn't really recommend, because right now, I'm stretching it on its width, and I'm stretching the height, so it's not taking that kind of default aspect ratio of a square. But we can also adjust the exact dimensions that we want. I'm not going to cover that today, but we can also specify basically the aspect ratio. But anyway, so here's our plot. So we have sine of x in blue, and then 2 sine of 3x in this kind of orange, kind of red color. Okay, so now what I'm going to do, I'm going to add a title, an X label, and then a legend. So for the title line of code, doing title, and so first off, I'm going to write out this line of code, and then I'll discuss, what it all means. So title, sine of x. Yeah, I did sine of x first, okay. And then versus 2 sine of 3x, that's what we had. And then interpreter, get out of here. And then LaTeX. Okay, so let's talk about this line of code. So our title is going to show sine of x versus 2 sine of 3x. And then I have this, these two arguments here, basically. So interpreter and LaTeX, I'm telling MATLAB to interpret the text that I have as LaTeX, basically like a LaTeX typesetting format. So I briefly talked about LaTeX last class, but that's against a typesetting format. So instead of like Microsoft Word, you can use LaTeX. LaTeX is good at displaying math, especially. So inside of these dollar signs here, that's going to specify interpret anything inside the dollar signs as LaTeX text. Okay, so we're going to do that. Let's run this now. As you see up top here, sine of x versus 2 sine of 3x. Kind of small. We could change the text size, but I'm going to leave it for now. And then we'll add an x label and then a y label. So x label, and we have to put all of this stuff inside of apostrophes. So x label is time. So for that, I don't need to use LaTeX. I'm not displaying any math. So I'll just leave it like this. I can write the y label on new line, or I can use a comma and then do y label, and then we'll do, I'm just going to write sine functions. Okay, there we go. And then we want to add a legend as well. So we'll do legend, and this is going to be, you need to write the legend as you wrote the code. So the first thing that we plotted was sine of x. So because of that, I need to do sine of x here. Again, I'm going to use this in LaTeX format. So $sign sine of x. And then now we're going to specify the second plot that we had, and that'll be $sign 2 sine 3x, $sign apostrophe, and then interpreter LaTeX. And I'll close that out. And then I'm going to add one more line of code here. Actually, first I'll run it right now. Here we go. All right, so here's our legend. So there's some issues here. Main one, it's blocking, it's blocking a curve here, and you should really try to avoid that. So I can maybe specify to put it down here. So I'll show you how to do that right now. Go into legend. So in quotes here, I'm going to type in location, and then I'll do southeast. Let's move that out of the way. So now if I run this again, now the legend is in the bottom right, so it's still kind of blocking it. We could just click and drag it and move it like that, or move it anywhere, or we could adjust our axis limits on the plot itself. I'm not going to show that right now, but we could do that as well, so we can make more room for the legend. But what I'm going to do is type in this new line of code. In general, I kind of prefer this anyways, but we'll do legend, and then box off, and then that's going to get rid of that outline that we had. And now we have the legend, and it's not blocking any of the curves. So maybe you would want to move this to the lower left, so we can do that. So that'll just be southwest. Run it, and there it is in the southwest. And this one isn't as good, so I can, I can just click and drag it though to move it. All right, so up to you. But once we start doing the labs, you want to make sure that when you have a legend, that it's not blocking a curve. All right. So any questions on what we've done so far? It's kind of been a lot of info.
Yeah, could you explain what line width does again and why you wrote 1.5 after that in the code?
Sure. So line width, that's just going to be basically the thickness of a plot. So by default, I'm guessing it's 1, but let's just really exaggerate this here and just change it to 5. Now if I run it, now that line width is, really thick. So it's really just a personal preference, but I usually like to do 1.5 or 2. It kind of depends on what you're plotting. So this is just a little thicker than the default line width.
Okay, thank you. And could you also re-explain what hold on and hold off does?
Sure, yeah.
Sorry, I got a little behind on the typing.
Oh, that's fine. All right, so hold on. That's going to be used if we want to plot multiple plots on the same graph. So I'm going to show you with this off first. So really quick too, it's kind of relevant. Let's say you want to comment out a lot of code, and you don't want to go in the beginning of each line and type a percent. That would get pretty annoying. So you can just highlight whatever you want to comment out, and then do Control and then R, and then you've got that all commented out. If you want to undo it, do Control and then T. So just kind of a random side note. All right, so let's do this first. That should be hold on. All right, so I'm gonna comment this out. So percent. So now if I plot this, it's gonna basically show us, it's not gonna show us 2 plots actually, it only shows 1. Okay, so there's that plot. And okay, we have this error here because it's ignoring our extra legend stuff because we only had 1 plot, and our legend shows 2 things. So let's, I want to make this a bit cleaner to show you. Okay, so let's say this is all the line of code that we had. So we have 2 plots here. If I was going to run this right now, I'm only going to get 1 plot that shows up. Okay, so that's happening because we have 2 plots, but it's basically this line of code right here. It's overwriting, or actually it's only plotting sine of x. So let's run it again. No, sorry, 2 sine of 3x. Okay, so what Matlab did is it first plotted this line of code and made that plot, but then it sees a plot command right under it. So it overwrote that plot that it just had, and it plots 2 sine of 3x. So if we have multiple plots, we can fix this by doing figure and then 1 for the first plot, and then figure 2 for the second. Now if I run this, now here's 1 plot, and then here's the other plot. Okay, but your question was on hold on. So I want to have both of these plots on the same graph. So again, right now it's only plotting 1 plot. It's only giving us 2 sine of 3x. So if I want both of those plots on the same plot, I do hold on. So that's telling Matlab, okay, make this plot, but hold on, I'm not done yet. I want to add another plot to this graph. So then we do hold on, and we plot. And then once you're done with all of the curves or the functions that you want to plot, you do hold off. Then if I run it again, now we have both curves on the same plot. So did that make sense?
Yeah, I got it. Thank you.
Okay, yeah. All right, any other questions? Okay, so I'm gonna, well, first I'll pull something up. Okay, so EOM example, I think this was it. Yep, I'm gonna run this right now. Okay, so I was kind of planning on going over this today as well. So what I have here is a graph. We'll go to the code. Actually, I'll show you the slides. So I was planning on also going over, basically going over a differential equation. So in this case, there is a spring mass damper problem with an external excitation in the form of a cosine wave. And I was going to show you basically how to do this inside of Simulink, and then also going over an analytic solution, and then plotting both the analytic solution and what we had in Simulink and comparing those plots. Thing is, this would probably take at least another hour. So up to you if you want to do it. It's not a huge deal if we don't, because the first lab is very, very similar to what we're doing here. So I don't think you'll lose out on anything if we don't cover it. But if you want to cover it as a class, let me know. Or you can just talk to me after class if you want to kind of go over it. So up to you. So again, we're going to be doing something very similar for the first lab. So in the chat, you can kind of decide.
Is the tutorial on your lecture notes?
It is just besides the analytic solution, but we'll go over something very similar in the first lab. Or I can send you my scratch work if you want to look at that. But the code and the Simulink model, that's in the lecture slides. Okay, so do you guys want to see the analytic solution too? I can upload those notes as well. All right, so I think we're gonna do that. But if you do, because everyone's saying we'll just go over it in the next lab. So no one's saying to not, or that they do want to go over it now. But so basically what I'll do is, if you want to leave now, that's fine. And again, we're going to be going over the Simulink model. That's very similar to what's in the lecture slides here. Next class, or maybe not next class, but the class after. And then we're also going to go over how to go about the analytic solution. That's also very similar to this next class. But if you do want to kind of talk about it now, you can stay on the call and we can talk about it. But if you want to leave, you can leave now and then we'll pick up next week. Yep, so for those that want to dip on out, you can go ahead and I'll see you guys next week.
Hey, Patrick, you said something about unsubscribing to a book or something at the beginning of class.
Yeah.
Can you go over that again?
Mm-hmm. So by default, you might be, okay, so right now I just signed into the Cal State Fullerton website. So I'm on the main page. And if you see under my courses, you might see some of your classes have a textbook assigned to it. Yeah, you guys have a good day too. Okay, so some of your classes, they might have a textbook and it'll say view course material. So like for this class, I have one. So I can click on it there. Okay, gotta sign in. All right, and then it's gonna take you to this page here. So by default, this semester, Cal State Fullerton is opting every student in to buying a textbook online. So if you want to opt out and not be charged, you need to go on that homepage, click on the course material. This will pop up, and then you can opt out of being charged so you don't get the textbook or the charge. You just click opt out.
Okay, so if the part that says view course material is not there, does that mean I'm not enrolled?
Yeah, I'm not seeing the view course material option either.
Yeah, if you don't see that, then it just means that there's no textbook that was assigned to that class. So then you shouldn't get any charge or anything like that. You're still in the class, but there's no textbook for that class.
All right.
That makes sense?
Yeah, I just want to make sure I'm not getting charged for things I don't need.
Yeah.
Wait, so do you have one for this class, or are you just letting us know for other classes? Because I don't see one on this class.
Yeah, there shouldn't be one for this class. I'm just letting you know in general.
Oh, okay, thank you.
Yeah. All right. Anyone have any questions? All right. I'm going to stop the recording at least.